Hey guys, in this session let us see the introduction to Cassandra and NoSQL databases. So we already know what a database is, right? So database stores data, to be simple, right? Either in the form of tables, right? So we already know about RDBMS software, right? Which is the traditional software used for managing the data in an efficient way, right? And typical RDBMS softwares include Oracle, MS SQL, MySQL. So there are a lot of databases in the RDBMS world, right? So this is a very widely used software in the IT industry, and it also provides enterprise systems, and we also have open source, right? So RDBMS solve a specific problem in the industry. Okay, so it normalizes the data, and also it provides transactional level support, and it has multi-version concurrency control, right? It uses locking mechanism to maintain consistency, right? So RDBMS software can be used if the data is not growing very big. Okay, it can support in maintaining the data to a certain extent, but if the data size is going in petabytes, right? So max it can support TBs, terabytes. Okay, so if it is more than that, even though if it is able to support higher volume of data, but still there are a lot of drawbacks in terms of performance, okay, in RDBMS. And also complex joins which are very expensive are used in RDBMS. Why? Because multiple tables needs to be joined to avoid any duplicates, and we need to get the results. So for joining multiple tables, lot of resources are required. Okay, and also RDBMS is not horizontally scalable. Okay, it is only vertically scalable, which means we can only increase the power of CPU, memory, and IO. We cannot add multiple servers. Okay, but in distributed databases, so Cassandra is a distributed NoSQL database, which means I can store the data in multiple multiple servers. I can install multiple databases on multiple servers and store the data, and I can split the same data across multiple nodes. Okay, so that is the main goal of NoSQL databases, to store big data and to provide fault tolerance, to provide scalability. So you can see all these benefits, and it also provides high availability. Okay, so Cassandra is a database which was designed as inspired by Amazon DynamoDB and Google Bigtable. Okay, so it is an open source database software. Okay, so it was developed by Facebook for its internal use. Okay, for searching the inbox in the Facebook message. Okay, and later it was the developers of Cassandra they were grouped together in a company called DataStax, and they were offering enterprise editions as well for Cassandra. Okay, but we also have open source which has limited support, and new features may not be there in the open source systems, but many advanced features are offered in the enterprise systems, okay, like additional tools and features. Okay, but even in open source we have development for each and every release. There will be some upgrades and updates as part of Cassandra. Okay, and Cassandra also uses commodity servers which are quite inexpensive, okay, very cheap compared to RDBMS. Okay, so why we are comparing these databases to RDBMS? Because NoSQL database solves the challenges which can't be solved by RDBMS. So that's why there is an alternative to RDBMS for different type of problem. Okay, so to store big data in an efficient way and to provide good performance and throughput, NoSQL databases are efficient to handle high volumes of data. But in RDBMS systems, we will be having some expensive servers, okay, with high resource. Okay, but commodity servers, even though they are prone to failures, okay, they are not robust in nature. Okay, they are like low quality servers which can fail anytime, but still, because of the multiple nodes on the clusters, Cassandra can offer good fault tolerance. Okay, so next let us see the challenges in RDBMS. Okay, every system will be having both advantage and disadvantages. Okay, so we see the challenges of RDBMS because why we need Cassandra, we need to understand, right? So performance issues happen when the data is normalized till third Norman form. Okay, so there are multiple Norman form in RDBMS, and we have asset compliance rules. Okay, so based on that, we need to make sure that we are normalizing the data to avoid redundancy of data, right? Like duplicate records and to maintain the consistency. So when RDBMS is normalized to third normal form, scaling issues were observed. Okay, and also complex queries with multiple joins consumed lot of resource. Okay, so if high resource are utilized, definitely performance will go down, right? And large data sets and less resource. So if the data sets are huge, right? So if I just normalize the data, I need more complex table relationships. Okay, so at that point of time, I may need to join multiple tables. I may need to use primary keys, foreign keys, and a lot of keys to make sure that they are connected to each other and there are no duplicates, right? And also I need to focus on consistency, right? So for that reason, RDBMS was having these kind of challenges, but still they can support the business, but yeah, again with certain disadvantages. Okay, so they were also having sharding issues. Okay, so sharding issues, so we just split the data across multiple shards, which means multiple different systems. Okay, this data will be distributed, but still data needs to be denormalized. Okay, we will not be able to use aggregates and joins when the data is split across multiple shards. Okay, also when we add new shards, the data needs to be again moved to the new shard as well. Okay, schematic changes become quite tedious, right, due to change in multiple shards. Okay, so it's kind of a complex system where if we need to change certain things, it will be difficult. Okay, so in the beginning of the application development itself, all the schematic relationships and all the entity relationships are designed, right? So when the data grow, right, to a huge volume, it will be very difficult to maintain those things. So that's the reason we get performance issues and lot of challenges in terms of maintaining the system, right? And also sharding always rebalance the data. Okay, so for rebalancing also it will take a time. So these kind of challenges were there, and also many skilled DBAs were required, okay, to manage the data which is huge. And also they should be skilled to maintain complex systems in RDBMS, right? So these are the basic challenges. There are also other challenges, but also there are other benefits as well. Okay, it is not that completely RDBMS does not support data which is huge. They can also support big data, but there are quite trade-offs which are limiting those systems, right? So why we need to focus on NoSQL? So NoSQL can scale as per the data growth. Okay, so say for example Facebook. So in one day, the amount of data which are generated can be in billions or trillions or more than that. Okay, per minute there will be almost millions of posts, right? Since users are the users who are having accounts may be all over the world. Every person who is using Facebook may be posting something, updating something, commenting something, liking something, right? So everything needs to be stored. So for that reason, data will be per day data itself would be very high. So just imagine. But in RDBMS systems, if say consider we have a banking system, or we have a healthcare system. Okay, so in older days, the data generated was very less. Okay, why? Because the use of internet was also very less, and everyone all over the world does not have access to internet, and also any social media or any other systems, right? The only organizations who manage data were banking, healthcare, and automobiles. Those organizations who are having those internet access and to store the data with the help of computers were storing some data. Okay, so limited data were generated. So that's the reason RDBMS was able to handle those data. But today, since we are using a lot of social media accounts, LinkedIn, Facebook, Instagram, which generates huge data, right? So that data needs to be supported by only NoSQL databases, or we can say distributed or big data. Okay, so NoSQL databases are distributed in nature, which means multiple nodes can be supporting the incoming data. Okay, and also there are multiple different types of NoSQL databases, like graph databases, and it goes on. Okay, but we need to focus only on Cassandra. So Cassandra is a column family database, and what is a column family database? It stores the data in the form of columns, not rows. But RDBMS, if you see, every data will be stored in the form of rows. Okay, but RDBMS also has columns. Okay, but the data which is stored will be in the form of rows. Okay, so even in column family databases, we will be having rows. Okay, but all these columns will be handled separately. Okay, so we don't call it as a one whole row, we call it individual rows, and when the data is required based on the ID, partition key or ID, it will just check the particular row. Okay, so one row may contain million columns in column family databases. Okay, but in row oriented databases or RDBMS, we will be having limited columns, right? Max we will be having 100 columns. Okay, that is also very rare. So 100 columns will be containing million rows, something like this. But in column family databases, it is vice versa. Okay, so Cassandra also stores the data in the form of row oriented. Okay, using the partition key, it will just partition the data and store. But still, the high level storage of Cassandra is column oriented. Okay. So why we need to use Cassandra, right? So we have a lot of advantages. They are distributed and decentralized. So distributed means if I have one database, I will store one table here. Okay, I can also add any number of nodes like this. Okay, and I can distribute the same data in multiple nodes, the same table on multiple nodes, and I can add how many nodes I want. Okay, so data will be distributed like this, and it is also decentralized. Okay, so what is decentralized? So there is no centralized system. Okay, so in traditional or RDBMS systems, we have a master-slave relationship. Okay, which means one node will act as a master, and there will be multiple slave nodes which will perform some work, and it will just update the details to the master node. So master node will contain some global information about all these individual slaves. Okay, which slaves are storing the data which I am requesting, right? So each and every slave will be storing different data, and they may need to coordinate it with each other with the help of network. Okay, so there will be a single point of failure, right? So if the master node itself becomes down, right, so we need some high availability system to make sure that the availability is maintained, right? So if master node itself becomes down, then obviously all the slaves who are performing also may not work. So each and every database may be having different ways to solve this problem. Okay, like Oracle, MySQL, MS SQL. So in Oracle we have RAC, real application clusters. Okay, so in real application clusters there will be multiple nodes. Okay, and each and every node communicate with each other. Okay, and there will be one master node which will store a particular amount of data. Okay, and another master node which will be storing another set of data, something like this. And when a client requests the data from this node, okay, if the data is not there, okay, and the data is stored on this particular node, who is the master of this data. So what this node does, this node will request the data from this particular master node, and then it will receive back the data. Again it will serve the request. So something like this. But in Cassandra, all the nodes are peers. Okay, so there is no master node master slave relationship. All the nodes are peers, which means every node are equal. Okay, all the nodes store some data. Okay, and based on the partition key, the data will be located. Okay, so there will be some coordinator node which will coordinate all the tasks. Okay, and there will also be a gossip process which will act as a intermediate which will just check the status of the nodes. Okay, with the help of partition key, say for example I have data from 1 to 300, and 300 to 600. So I'll just explain this later in the architecture session. So if I need data between 20 to 30, say for example, okay, based on the partition key, it will just directly go to this particular node. Why? Because 1 to 300 data is stored in this particular node. So something like this, right? So it has locally managed storage, okay, compared to HBase, right? So in Hadoop HBase, we use HDFS file system, but in Cassandra, we can locally manage the data, and Cassandra uses a storage engine which is log oriented, okay. So log structured storage engine is used. All the updates are written with the sequential IO, and data will be only appended, okay. So there is no modification on the existing files. So why? Because data is immutable on the files. Immutable means we cannot change once the data is returned to the files, okay. But in RDBMS systems, we can release the extents, we can remove, clear up the space and all these stuffs, okay. But in Cassandra, once the file is written, we cannot modify it, okay. It is only append only structure, okay. Then it supports different data types, right? Structured, semi-structured and unstructured, right? So we already know what structured, semi-structured and unstructured, right? So there are certain data which will not be in structured format, right? So if I need to store customers data, right, then I need to structure it in the form of tables, right? I need to use customer ID, customer name, then age, something like this. So these kind of data are structured, so they need to be structured in the form of rows and columns and with tables. So semi-structured store information like XML, emails and all these stuffs, okay. They may not be completely structured, but they are also not completely unstructured, okay. So coming to unstructured data are something related to audio, video, something like this, images. So these are unstructured, okay. So every data types are supported, and Cassandra distribute the rows with partition key across the nodes, okay. So we have a primary key in Cassandra, okay. We don't have any secondary indexes or secondary keys, okay. We have a primary key which acts as a partition key, and also there is a clustered key, okay. So with the help of this partition key, Cassandra will be able to locate the data across the node, and it is suitable for large data sets. It is also write intensive, and it is distributed. I mean, it is good for distributed databases, okay. So how Cassandra stores data, okay. This is just a high level view of how Cassandra stores the data. So this is called as ring diagram, okay, which I will explain later. So this ring diagram shows the number of nodes which are part of the cluster, okay. So we'll be having data centers, and each data center will be having a dedicated rack. So inside the rack we'll be having a set of nodes with replicas, okay. So data will be replicated between these nodes, okay. So in this ring structure, each and every node will be having a token value, okay. So that token value determines how the data is stored, okay. So every data that is generated, there will be a hash algorithm which will generate a hash value, okay. Based on the hash value, it will just check the range, data range, and it will put the data. If the data if the hash value is 350, then it will check the range. What is the range? 300 to 600. So this particular row will be put inside this node, I mean stored inside this node, okay. This is how at a high level Cassandra store data. And drawbacks. So in Cassandra we cannot use any joins. Okay, why? Because every table which are used may be independent to each other, and there may be duplicate data, right? So we don't join tables because that does not make any sense in joining the tables, and we also don't have any foreign keys, right? So in RDBMS systems, foreign keys are maintained. Okay, and there are no indexes in Cassandra. Okay, we have a primary key which acts as a partition key in Cassandra, but still we cannot create other indexes like RDBMS. So in RDBMS we have a lot of other indexes that can be created, right? But in Cassandra we cannot create any secondary indexes. Only limited secondary indexes can be created. Okay, and also data is immutable. Okay, so immutable means we cannot modify the existing data. It can only append the data, right? So this causes read overhead, right? So say for example, if I'm writing some data in a data file, okay, this data cannot be changed. Okay, so what Cassandra does is it will create a new file and it will append new data. Again it will append new data. Why? Because it cannot modify the existing data, right? So it keep on going until n number of files are created. Okay, so when there are thousands of files, okay, so when I just read some data from these thousands of files, obviously I should be having some RAM, good RAM space. If I have good RAM, then I can catch all those data and read from the RAM, because reading from the RAM will be faster. But if the data that I'm requesting is very huge, then every data cannot be stored on RAM, right? So RAM is a limited resource. So every data needs to be scanned from the SS tables, which is the data files. So if there are thousands of files and if I'm requesting terabytes of data, say for example, so it need to scan thousands of files. Okay, so reading from all these files will be an overhead. Okay, so this is one of the drawbacks. Okay, so there are still other drawbacks, okay, as part of Cassandra, but these are the major drawbacks. Okay, so this is the main goal of using Cassandra. Okay.